You see, regarding flow, you come across three situations: when the charge flows, when fluid is in motion, or even heat flows. In all the three cases, while studying the details of the flow, we come across the term current. Here, electric current, and in heat, you study thermal current. Both are analogous. You see, temperature gradient there and potential gradient here, both are analogous. The unit of electrical resistance is going to be ohm here, and this electrical resistance will also be analogous to thermal resistance. Or the resistance is equal to V upon I. It has got nothing to do with Ohm's law. This is only the definition of resistance, that is V upon I. But now here we are going to focus on Ohm's law. That's entirely different from this very equation. This law says that current flowing through any conductor is directly proportional to potential difference across it, with the condition that temperature and pressure, other physical conditions, should remain constant throughout. And if this is true, you see the graph between V and I is going to be the linear one. If it is exactly linear, obviously the conductor is going to be ohmic, but actually it is not the case in practical life. We find after a limit of voltage, either it resistance increases or decreases, means this proportionality is no more continued. You see, the deviations might be of three types. One is after a limit of voltage, as over here, and the second is on reversing the voltage. We find the graph is not retraced. That means Ohm's law is not followed exactly when the voltage is reversed. And the third situation is the graph is not similar. Symmetry is not there. Means at one particular voltage at you find the similar values of current at two different voltages, which is a peculiar thing. So this is also a kind of deviation, as in the case of gallium arsenide. We, in terms of drift velocity, we are going to get this relation V equal to ml upon n e square a tau I. If apart from V and I, you consider the whole thing is going to be constant, depending on physical conditions, if you maintain them to be constant, this whole bracketed, this expression is also going to be constant. So what remains is V proportional to I. This is what you exactly call Ohm's law.